Welcome again to the October issue of AJP-Heart and Circulatory Physiology's Table of Contents, or From the Editor's Desk. Today I'm coming to you from Kansas State University College of Veterinary Medicine, where I'm here to meet all the faculty and talk about our research. Some of you may know some of the people from this institution. One of them is Tim Mush, who often reviews for our journal and contributes really great work on exercise training, and its role in heart failure, especially from the microvascular level. So I'm going to let Tim say a couple of words before we get started.
First of all, I'd like to say that we're really happy that Irv was able to come down and be our Clarenberg lecturer for the day. We're really looking forward to a very nice presentation later on this afternoon. I want to encourage everyone that, with the upcoming issue in October, got great stuff coming in AJP Heart Circ, and keep on supporting the journal and provide feedback to Irv on how things are going.
Great, thanks, Tim. So we're going to highlight some great work today. So let's get started. Sos et al. Investigated the effects of high-fat and low-dose streptozotocin-induced diabetes on cardiac function and oxidative stress in rats. In the pre-diabetic state, with slightly elevated glucose, rats showed diastolic dysfunction, increased LV mass, and increased fat in the myocardium without an increase in fibrosis. Mitochondrial ROS was elevated. Expression of mitofusin 2 was increased, while the phosphorylation of phospholamban and mitophagy were decreased. Other markers of auto and mitophagy were unchanged in prediabetes. This study indicates early changes in diastolic dysfunction and mitochondrial oxidative stress in the pre-diabetic state. Wei et al. Examined the relationship between brain MAP kinase signaling and endoplasmic reticulum stress and sympathetic activation in heart failure. Sham and heart failure rats received intracerebroventricular infusion of the ER stress inhibitor TUTCA. TUTCA infusion reduced ER stress and reduced activation of MAP kinase pathway proteins in the subfornical organ and the paraventricular nucleus. TUTCA also reduced plasma norepinephrine. mRNA levels of ACE, AT1 receptors, and TNF-alpha, as well as NF-kappa B, were reduced in heart failure rats. These data suggest that ER stress contributes to augmented sympathetic nerve activity in heart failure via MAP kinase signaling pathway. Exercise has been linked to reduced blood pressure. Here, Otsuki and co-workers examine the effects of habitual exercise in the form of low-intensity resistance exercise on systolic blood pressure in middle-aged men and women. In normotensive women aged approximately 62 years, maximal oxygen uptake was correlated with systolic blood pressure. Physical activity or maximal oxygen uptake was shown to be a predictor of systolic blood pressure response during resistance exercise. Men and women aged 64 years underwent a 6-week training program or were sedentary. Systolic blood pressure during resistance training decreased in the trained group. These data suggest that habitual exercise decreases systolic blood pressure during low-intensity resistance exercise. Bay et al. Examined the effects of resveratrol on LPS-induced cardiac dysfunction. Resveratrol preserved cardiac function in LPS-treated mice. LPS reduced Circuit2A activity and increased superoxide generation and the monomeric form of phospholamban. These changes were reversed by resveratrol. Resveratrol treatment increased Circuit2A, the oligomer form of phospholamban, and NRF2 expression and function. These data suggest that the activity of Circuit2A in endotoxemia inhibited, possibly due to increases in the monomeric form of phospholamban. They suggest that resveratrol protects the heart from LPS injury in part by promoting oligomerization of phospholamban, leading to enhanced Circuit2A activity. Finally, Okich et al. Examined the fibronectin network and endothelial cell responses to shear stress in UVEX. Specifically, they focused on the heparin binding region of the first type 2 repeat of fibrillary fibronectin, otherwise known as FN31H. They hypothesized that FN31H is required for endothelial cell stress fiber alignment under flow. The results showed that the matrix cryptic heparin binding RWRPK sequence located in the FN31H is required for shear stress alignment. In addition, they show that flow-mediated endothelial cell stress fiber alignment is adhered via alpha 5 beta 1 integrin specific ligands and does not occur in the absence of FH31H. The study concludes that RWRPK of FN31H may have broad capability as a mechanosensory signaling site. Well, I'm back in Nebraska now, and I want to thank you for watching the October edition of From the Editor's Desk. I think we've had a great issue. I'm sure you'll enjoy it. And I thank Tim Mush and the group at Kansas State for a great visit. We'll see you next month. And don't forget, send us your best work now.